physics, topic by topic. Today we're going to have a look at centre of mass and parallelogram of forces. First we'll start with centre of mass and we'll have a look at what we can do with this. Simply put, what is the centre of mass? Well, it's thought to be the place where all the mass is, and we can have a look at that by perhaps having a look at a simple experiment with a piece of card. So what I'm going to start off with is this piece of card, and I'm just going to zoom out as much as I can, and let's start off with a piece of card. And what I'm going to do is just going to basically cut out a shape. There we are, a shape. Now, it doesn't look very regular, it wasn't meant to be, and I want to try and determine where its centre of mass is going to be. So what we need for this is simply a hole, and I'm just going to put a punch in here, and I'm going to put a hole in, and I'm going to try a hole somewhere else. Right, so there is my object with its centre of mass to be determined. Now, what are we going to do with this? Well, we need to have a look and see where it is going to sort of hang, and to do that we need to go and do the experiment. So let's have a look at this. Right, I've got then my piece of card, and all I need to do is basically to set up a plumb weight. So what I've got here is a small weight, and what I can do is I can suspend this on a piece of thin cord. It's going to be one of those days when it's not going to knot nicely. No. There. Right. I just thought that'd be a nice easy thing to do. I've got a piece of now a weight, and that's going to be suspended vertically. So what we now need to do is we now need to also put this piece of card in. Right, so what I want to do is I want to really just take a torch stand, in very tight. Okay, and what I want to do is I want to now suspend this, and I want something fairly thin to hold it, and what I'm going to use, if I can get one out, is a paper clip. And I'm just going to clamp this paper clip in. You can't quite see that, so I'm doing the filming by myself at the moment. I'm rapidly getting an assistant to help. Right, there is a I'll just put my card in. We're going to take this weight and I'm going to wrap this round a couple of times. I'm going to leave this to settle. I didn't manage that enough times. This string is not the best. No, I'll have to do it again. Right, so there is a piece of card. It is now hanging as its centre of mass. I then take this weight, I want to hook it on here, and I want to just tie it off so it doesn't fall. There we are. And what I'm going to do is I'm going to measure here my centre of mass. Now let's take this system to bits. And now I'm going to hang this the other way. No, failed again. This string is very slippery. Right. Pull it round so you can see. So now we've got our new centre of mass that way, and if we take it all to bits, which is why I don't really want to put the weight on properly, then if we get a ruler, then if I draw in from the centre of that circle along this line, and I draw in from the centre of the circle on this line, where the two meet here is the centre of mass. And this works with virtually any object you do. If you're going to try and get clever though, there's one we can always do like a centre of mass experiment. Then if they get you to do one of those, then there is nothing to stop you trying this one. And this one sort of is one that will probably cause the teacher a problem trying to explain this to you. What I'm going to do is I'm going to take out here a C shape, and let's cut this now to make a letter C. There we are. So let's have a look and see if we can do this as a centre of mass. So I'll just put a hole in there, will do. I can do a hole in there. And try holes anywhere you like. So there is my C, and let's have a look and see what happens with this one. So I have a problem there. Yeah, that's right. I'd lost the camera. Right, okay. So let's just hold this piece of metal in there. And I'm not going to do this one too much, but I will give you an idea of what it's going to do. So let's take my weight, and if we hang this weight now, we can see that the centre of mass, let's just try and get everything still, is there. Let's hang it from this point. It was there. And finally, let's do it from this one. Steady everything up. Back there. And if we take this one over here, I pressed the button by mistake. Right, let's look at what we've got. Well, I've got a centre of mass here. I've got a centre of mass there, and finally I've got a centre of mass about here. And where those three lines meet is about there. And we've got, interestingly, a centre of mass on an object where, well, there is no mass there. A centre of mass where it isn't. And if you want to try and ask your teacher to try and explain that one to you, they'll thank me, but not much. Right, okay, so centre of mass. Well, have you been on a bus? Yeah, probably not one like this, but here they're also demonstrating the centre of mass here on a bus, and you can see amazingly that that bus has been tipped to a phenomenal angle, and it's not falling, and it's a real picture, and it's a real test that they do on buses to make sure that they're stable. So let's have a look at why that bus doesn't fall over. Well, that bus isn't going to fall over simply because of centre of mass. So let's look at a simple road, and on that road we've got a bus. Here we are, there's our bus, and it's got its wheels, and the centre of mass on a bus is in fact very low. All the weight is concentrated fairly low down on the bus, so its centre of mass points down here. Now let's take the road and let's tip the road up, and I'm just going to turn this round and I'm going to draw my bus as I did before. There's my centre of mass, and now let's turn it round, and now my centre of mass here is there, and it's inside the wheelbase. Let's look at this photograph. We've got our centre of mass probably at around about this point, and straight down it's not going through there, even if it's right at this point, and that's the centre of mass of the bus. It's still not going to fall over. However, if we tip this angle too large, and what I'm going to do is I'm going to just draw my bus in again, there's my centre of mass. Right, let's have a look at it. Now here my centre of mass is outside the wheel, and therefore the object is going to topple over. I've done some various other experiments on centre of mass which are done on an inclined plane, and I'll show you some of those either later in this video, but probably next time. So there is this idea of centre of mass. If you do it of a symmetrical object, then this is really quite easy, and this is normally what a teacher would probably try and get you to do, and that is by taking something like a triangle with equal sides. That was no help. I marked a piece of paper rather than the card. Then if we've got an object which is symmetrical like this, then if I've cut a hole there, then what we would expect is the centre of mass to be easier to find. If you take an equilateral triangle, then it's going to be right in the centre. So there is an idea about centre of mass. We haven't quite finished there, and let's look at one other item of centre of mass, or two actually. There's this one, and I've got my hanging basket. It's just come in, and if I put my hanging basket in an awkward position, then what it will do as soon as I let go is it will try to get back to its centre of mass, wherever that may be. So if I just tilt it, it's going to go back as it was. I'm going to move that before I clonk my head on it. There's a clever trick though of another one, and this is a broom, and all you do is you want to find where the centre of mass of this broom is, and all you do is you bring your fingers in. Now I'm trying to bring in both fingers at the same time, but this one is moving, and then I can move my other one, and we move in, we move in, we move in, and my centre of mass is going to be just between those two fingers. And there is my centre of mass of my broom. Right, so that wasn't quite what I planned. Okay, so there is this idea of centre of mass. Not necessarily the centre, like the broom. It's got a heavy end, so it makes an odd shape when you try and balance it up. So let's have a look now at the next item I want to have a look at. So that's centre of mass. And what I want to look at now is something about a parallelogram of forces. Now let's have a look and see what we mean by this, and there's a couple of experiments we can have a look at. So let's try one of these. So if I take those to bits, in fact I'll just tighten my retort stand up. And what I'm going to do is I'm going to put a couple of pulleys on this retort stand. And if I can, I'll put it in there. And we'll do the same with the other one. And there, that gives me a couple of pulleys about the same height. And what we can do is between these we could place a piece of string. Now I'm going to tilt this round. Try and make this go the right way. Lay down. And there's the other side. Right, I don't need all this string. What I'm going to do is cheat in a minute, and what I'm going to do is I'm going to put a couple of weights on here. That wasn't as helpful as I wanted. Right, so these are the same weight, same mass, at least they were till it fell over. And what I'm going to do is make a little knot in here to hold my weight. Right, if I just pull these apart, then these two masses support each other. Now what happens if we take another weight and put this in between? So I'm just going to tilt that round a little bit so you can see it hopefully a little bit better. And what happens if I move this, came off the pulley again, what happens if I move this to one side? Just and you'll see that it doesn't matter what I want to do, it wants to put itself back suitably. So I've got here two masses here that are the same mass, and we've got one in the middle. What happens if we make this lighter? Obviously it's not pulled down as much. The greater the mass here, the more it's going to pull down. So if I were to double its mass here, then we've got a much bigger force pulling down, and so we're getting a change in this force. And there you can see I've got 200 in the middle, 200 either side, and it's just about going to cope with that. If I pull these down, it's not going to work. They're going to have to go right up. So here we can sort of start to investigate how these forces work. Well, we can try out various experiments like this, and what we can do is we can try and see how the angle varies as we change the masses. But I want to try a slightly different experiment now to sort of explain what's going on here. So we're going to start with a slightly simpler version of this and see what we can do. What we're going to have a look at, experiment looking at a zip line, and we're going to try and make ourselves a simple zip line experiment. Now, what this involves is simply having our two retort stands like this, and what we're going to do is we're going to put a piece of string between the two, and we're going to vary the height of this string. And what we're going to do is we're going to take a little metal hanger, and what we're going to do is we're going to release the hanger at point A, and it's going to go down until it finds somewhere that it's going to be happy. So we release it and we observe where it comes to rest, and we're going to look at how the height difference between this one on side A is going to vary with the one on side B, and we're going to have a look and see what happens. Now, if you're going to do this, if you're going to use weights that are reasonably heavy, then it's necessary to clamp these down. We're not going to use a very long line, and we're not going to use a very heavy mass, so that's not going to be a problem for us. So let's have a look and see what we're going to do with this. So let's have a look and see our setup. let's move the clamps out of the way. This string is going to be too thick, so what I'm going to do is I'm going to use this very thin stuff that I used earlier to try and have a look. So let's start off with a clamp. I'm going to make sure the base of this is going to be pointing on the base of the other, so when it pulls it's going to try and pull in. And what we want to do is we want to just tie a string to this, and the easiest way I've found doing this is simply to turn one of these sideways, and what we're going to do is we're going to put my little loop on one side. So there's my string going to go across to the other side. On the other side we need to set it up in exactly the same way. And what we want to do is we want to set up a string something like about here. Right. I'd lost my pair of scissors. Now what I'm going to do is, because this is particularly horrid string, useless. I should get someone else to do this. The string here is really horrid. There, done it. Alright, so I've got my zip line, and let's take a small mass, there's just 30 grams, and what we can do is we can let go, and that's going to stop reasonably close to the other side. Now in fact if we have this a little bit loose, then it gives me a distance. So what we want to do now is start measuring the heights, and I failed to get myself a long ruler. So what we're going to do is we're going to have a look at these things. It's alright. The good thing is if I call out for a ruler, someone will usually get me one. So we've got here the height between A and B, and I'm interested here merely with the difference in height between A and B. So I've got the height of A, the height of B. I'm going to get my difference, and then what we can do is simply put in here my next bit, which is my distance from B. So let's start our first one. This is A, and my height here we're going to take as 57 centimeters, and my height of B, these were just done at random, this is 22 centimeters. So if we simply take one from the other, that's going to give me 35, and my distance from B here is 6 centimeters. Let's take this one up by 5 centimeters. So I'm going to set this at 27 centimeters. Let's let the zip line go. So A is still at 57, B is at 27, the difference here is 30 centimeters, and my difference here now is going to be 9 centimeters. Now, does it matter about the floppiness of this? If I make it a little bit tighter, is it going to make any difference? And hopefully you can see there is a difference, because now I've got a distance of 4 centimeters, which was less than we had on the first time. So you can see that it's going to be necessary to run this several times. I've got 4 centimeters. So what we've got to do is we've got to ensure that the string basically is going to have about the same amount of give in it each time that we try and do it as we change the height. So adjusting for our distance, we've got 4 centimeters there. Let's take this one up now to, was 27, so this time I want to go to 32. Trying to hold a ruler and a clamp, bit of a problem. I'm going to take a little bit of tension in there, so it's got about the same amount. And this time I've got 8 centimeters. So 57, this is 32, the difference now is 25, and I said that was about 8 centimeters. Let's do it again. that time 9.5. I've chosen slippery string because it seems to work better with that, and that time it's about 9. Realistically, you sometimes may need to do as many as 10 here. That's 9 this time. And it's going to vary according to how taut the string is. That one didn't do so well, and that one is a massive 12. So I've got quite a lot of difference here without making much change. Let's take this up another 5 centimeters. We're going this time to 37. Trying to get the tension in the string right each time. Still a problem with this experiment. And we can see, however, there is still now a massive difference. So that is 24 centimeters. Do it again. This time 24.5. Maybe my string isn't as taut as I needed it to be. 24. And you'll see that if I change the tension in the string here, even by a fraction, it's going to make quite a difference here, and that is 27.5. If I pull this up a little bit tighter, then you can see it's stopping much further. So if I make the string taut each time, then we can get perhaps better readings, like 48. So you have to try and decide on how taut you have the string. If I make the string as taut as I can, and there I can get a little bit of vibration out of it, and I'll let it go, then we can get very different sorts of values. That's 59. We'll do it again. $57.5. You can see it's not really moving terribly well. How could I make this move better? Well, the only way I could probably make this move better is to sort of put a bearing on this. But I do have a way I might be able to make that a bit easier. So what ways could we try and modify this so it would actually move better? And one of the ways is to put some wax on there. I could put something like some candle wax on there, and it might move better rather than just getting stuck. This works better if I have a greater slope, and as long as I've got the greater slope, and here we've got a distance of just, I didn't quite get 7, I'll go down a little bit more. So there is 7 centimeters here, let's pull the string reasonably taut, and now if I pull it down, you'll see that at that point it's just going to collide. So what we can do is, as long as we keep this experiment reasonably consistent, we can get out some reasonable figures for this, whether you want to have it loose which is better really, or whether you want to have it tight. If we have it fairly high up, these are now nearly the same level, and I leave this fairly loose, then we can get, again, quite accurate readings. So you can get the same sort of readings whether you have it tight or loose, and you have to decide whether you have it this loose, in which case you get to 36, 37, 36, or if I make it quite a lot looser, am I getting to a different position? You can of course measure the other way, which is to measure the length of this string. So that's going to give us 32, 33, 31, and if I have the tension tighter, 44. So you can see how this does not work that effectively, and you have to put in your own parameters about how taut the string is. But if you can keep the same tautness in the string, then you can get a series of figures that give you some sort of inkling about what's going to happen. If we have a look and see what we've got, then we can see from these figures, which are not really helpful, but we'll look at the difference here. We can see that if we plot the thing that we are changing, which is the difference at the bottom, so what I'm going to do is have here 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. We're looking at the difference here. So we're looking at our difference, and we're looking at the distance that we got along this side, and the distance here is going to vary really quite a lot. So I'm going to do 10, 20, 30. We can see that when we get a difference of 20, we had about 24, 25. When we had a difference of 25, then we've got something about 9. When we've got a difference of about 30, it was about 4 or 5, and if we had here further, it's going to ramp up, which is going to give us a graph, which is going to give us a shape something like this. So we're going to get some sort of curve, and I have to admit my values here are quite considerable, what we would term error bars. The margin for error becomes quite large because of my tautness of my string. But what are we seeing? We're seeing here something about a parallelogram of forces. We can't seem to use logic on some of this maths to try and work out what's going on. If I've got my first experiment, which I want to come back to, when we put a pulley up the top, then depending on the masses that I have at either side, and we only did this with a mass that was the same at either side, when I put this mass here, as we changed it, we saw as this increases, therefore the angles increase. They also go up. So as the mass increases, so the angle increases. What happens if we change the weights here and I make this one large and this one small? Then what we find is that the position then of this mass changes. If they're the same, it's in the middle. If it's not, it's going to move either way. And we've got relationships between these and these angles. If I were to draw this here with a point going down here, I can measure these angles, and as we do so, we have to worry about the sine and the cos of these angles to try and work out what's going on. Well, we need to investigate some of these parallelogram of forces to try and find out what's happening, and we need to sort of look at how we resolve these forces. And what we'll do is we'll do that next time on GCSE Physics Topic by Topic. I hope that's been useful. If you did, then please subscribe and give us a thumbs up, and I'll see you next time. Take care. Bye bye.